Determine the mass that must be supported at A and the angle of the connecting cord in order to hold the system in equilibrium. So we are going to find the mass at A and theta. Let's just jump right into our free body diagram. We are really just concerned about what's happening at D, and we can just use that as our free body diagram. So we have this tension, and we're going to call it TA, because whatever is happening here is the same as what's happening here, because it's a pulley. So those have to be the same. So that is the same as mg, or mag. Then we have our force coming off in this direction, which we will call FC, or TC. We'll call it FC. That's what I've written down. FC, which is the same here as it is here. So that is our 30 kilograms times 30 kilograms times gravity. That's the force. And then we have the force coming off here, FB, which is equal to 40 kilograms times gravity. And that's the weight at B. And we know this angle is 60 degrees, and we need this angle, so this is unknown, of theta. So we can solve here with our equations of equilibrium. The sum of the forces in the x direction, we have mg a cosine of theta for this TA component, minus 30 kilograms times g times cosine of 60 for the x component of my FC, and that's equal to 0 because I don't have any x components of my FB. Then in the y direction, I will have negative 40 kilograms times gravity for my weight at B, plus MAG times the sine of theta, so the y component of this, the force TA, is the sine of the unknown angle theta, plus 30 kilograms times gravity times the sine of 60 degrees is equal to 0. I can solve this, the first one out, the x direction out, to be, all my g's are going to cancel out here, and then this is a scalar, so I get m cosine of theta is equal to 15, and I'm going to call that equation 1. And similarly, in this y equation, I have these g's are going to come out, and then this is a scalar, and this is a scalar, so I have MA times the sine of theta is equal to 14. So that's my second equation. All right, now I'm just going to use algebra, and I'm going to solve for this. So if I divide equation 2 by equation 1, I have m sine theta over m cosine theta, which I can recognize as tangent right there, is equal to 14 over 15. So I end up with tangent of theta is equal to 0.933, and theta then is equal to 43.0 degrees. Then I can sub that into either equation 1 or equation 2, and I can say m sine of theta, m sine of, and stick theta in there, 43.0 degrees is equal to 14. So my MA that I've been caring about, MA is equal to 20.5 kilograms.